been given a numerical problem. Obtain economic scheduling for the unit having following data for a load of 5 megawatts in steps of 1 megawatt using dynamic programming. Is the question. Then you have been given two cost functions, C1 0.75 P1 square plus 50 P1, C2 0.50 P2 square 25 P2. Now in the interaction we have understood dynamic programming is useful when we have a series of decisions to be taken. Now for a megawatt of 5, how these two will coordinate among themselves, and which is that combination of megawatt delivered by unit 1 along with the unit 2 is most economical, can be obtained by simplest decision taking process. In case of priority listing method, number of combinations need to be checked, but over here it is quite easy from the available parameter in a set, like elements in a set, the value of the particular position element which is least represents the combination of the generator for your requirement. In that regard, let us take the particular cost of production of 1 megawatt, 2 megawatt, 3 megawatt, 4 megawatt, 5 megawatt from machine number 1. Similarly, 1 megawatt, 2 megawatt, 3 megawatt, 4 megawatt, 5 megawatt production from machine number 2, and let us put them together as a total production cost for 5 megawatts by combining these two units in a proper fashion. If machine 1 delivers 5 megawatts, what is the contribution from the machine number 2? 0 megawatt. One option. If machine 1 delivers 4 megawatts, what is the contribution from other machine 1? Like that, I will be combining net megawatt of 5 into loading on machine 1, machine 2, and I will evaluate the cost of production of respective combination as a comparative terms in a bracket. In this set, then from that set, I will identify the one which is lowest by value, by representation, I will pick as a combination result. In that regard, I will start. Let us say solution. Okay. Let us obtain cost of production from unit 1, I write here, unit 1 for all the slabs. Like I will write here F1 5 megawatt equal to 1. That is, I write here. That is, what is the cost of production of 5 megawatt from this machine? In the position P1, I put 5 and I will tabulate all the values of machine 1, machine 2. Then I will use in a string, it will become a complete numerical solution for me. Now, if I want to write this, how I will be writing? It is 0.75 into 5 square plus 50 into 5. What is the value of this? If I numerically solve this value, I will be getting the numerical content as 268.75. 268.75. Similarly, if I want to work like F1 for 4 megawatt, in the same equation, wherever 5 I have located, I will now locate 4 megawatt. So that will be again 0.75 into 4 square plus 50 into 4. What is the value of this one? The same kind of calculation I will be doing for this. This will represent me F1 for 4 megawatt as a numerical content 212. Likewise, I should do F1 3 megawatt. Nothing wrong if I start F1 1, 2, 3, 4, 5. I am going in a reverse order. It is not wrong if I go with 1, 2, 3, 4, 5. Absolutely acceptable. There is no doubt about it. Okay. Then this will be 0.75 into 3 square plus 50 into 3, which works out numerically a value 156.75. Now we got a workflow. I will go down to production cost from machine 1 for 2 megawatt. This 0.75 into 2 square plus 50 into 2. I work it out. If I make it, it will be a value 103. You can cross check. 103. Whatever is the standard equation we have, from that standard equation, I am substituting the relevant content and I am trying to evaluate it. Then similarly, F1, 1 megawatt, if I want to produce. In this 1, if I locate 0.151 square plus 50 into 1, becomes 0.75 into 1 square plus 50 into 1. Which ultimately lead me a value of 50.75. Okay. Now I could do evaluation of production cost from machine 1 perspective for all the slabs, 1 megawatt, 2 megawatt till the last one 5. Similarly, if I keep the calculation pertaining to machine 2, it's very easy for me. What I will do? Similarly, for unit 2, F2 5, F2 4, F2 3, F2 2, F2 1. If I keep ready, nothing wrong. One I'll show you. F2 1 means it is 0.5 into 5 square plus 25 into 5. This is what? 0.5 into 4 square, 25 into 4. 0.5 into 3 square plus 25 into 3. 0.5 into 2 square plus 25 into 2. 0.5 into 1 square plus 25 into 1. I wrote all the possible combinations. Now, only thing is I have to fill the numerical value. If I am not wrong, if I would have done the calculation systematically, I will be able to get these values from the calculator one by one. I have the values here. What are the values I have with me? This value of 5 megawatt return me 137.5. I have the solution with me. With the 4 megawatt, I have 108. I have 3 megawatt, 79.5. Clear? 2 megawatt, I have 52. Then for the 1 megawatt, I have 25.5. Very simple. The work, what I would have done for the machine 1, similar work, I kept it ready. Now with me to just to make the terms in a flower bracket as a element, as a combination of megawatts of machine 1, machine 2 together, matching for the 5 megawatts, all I have to write. Then I know for the given schedule, what is that? I have production cost of 5 from 2 units is equal to production cost of 5 megawatt from 2 units is equal to your minima. Let me write the expression and I will write the representation other side. It should be minima. Clear? Min of, or I should write one of the machine I take as my first decision. I will take first machine as my definition. I will write F1 5. Is it possible to complete here? Not possible to complete. So I will pick this term on the other side because it becomes lengthier expression. So what I will do? I take out this portion. Okay. Okay. So F for 5 megawatt from 2 units is equal to min of F1 5 plus F2 0, comma F1 4 plus F2 1, F1 3 plus F2 2, comma F1 2 plus F2 3, comma F1 1 plus F2 4, comma F1 0 plus F2 5. These are the possible values. Clear what I did now? Total production cost for 5 megawatts from both the units should be minimum possible by the combination of these two units is my target. For that I have prepared production cost from machine 1 for different slabs of megawatt, production cost of machine from different megawatts I wrote it. Here I wrote considering one of my machine as best and that to be evaluated, but I use both the sides capital F notation for the easy. And these numbers I will use in the respective position. When machine 1 is my decision, machine 2 is to be checked for optimal, like this. My step is now to just to pick the content one by one and position in the respective slots. Now what I will do? The first term, this is equal to minima of. Clear? Minima of. What is the first one? F15. Can you see? F15. What is the value here? 268. 268.75 plus F20 from this particular second machine or first machine. If I put 0 megawatt, value turns to be 0 because there is P1 square, P2 square, P1 into P2. That whole expression when megawatt is 0 turns to be 0. Therefore, from the second term, this value goes 0, comma. What is F14? F14 is there with me. This 212 plus. What is F21? 1 megawatt if I obtain from this machine. What is the value here I have? 25.5. 25.5, comma. What is the third one here? F1 with 3. F1 with 3 turns to be 156.75. 156.75 plus. What is F22? F2 with the 2 megawatt loading. The value is 52. So I write here 52, comma. Then I come to next line. F1 with 2 megawatt. F1 with 2 megawatt. What is the value here I have? 103. I write here 103 plus F2 with 3 megawatt. F2 with 3 megawatt. What is the value? 79.5. I write here 79.5, comma. Then F1 with 1. I am coming down. What is the value of F1 with 1? 50.75 plus F2 with 4. F2 with 4. What is the value you have here? 108. 108, comma. What is the last term? The last term is F1 with 0. Definitely 0 plus F2 with 5. F2 with 5. What is the value? 137.5. This is your final conclusion. So this, if I simplify, So I take this line out. If I simplify it, what is the value I'm going to get? I'm going to get numerical value of each combination with the comparative term. So I have the answer with me. This is equal to min of the first term 268.75. The second term refers to 237.5. The fourth term refers to 208.75. The next term refers to 182.5. The next refers to 158.75, comma, the last refers to 137.5. It means each term, when I simplify, I'll be getting numerical value. Now, for you, production cost being minimum for 5 megawatt from both the units or 2 units is one of the combination from this set. Now, you only tell me which is the most economical value for me. First combination is 268, second is 237, 208 fraction, 182 fraction. I think this turns to be the best value. This I'll put as a star. This is your choice because it is the lowest in the possible combination. Then what is the indicator here now? The indicator for you is, if you go back, last combination. What is the last combination you have here? This is your solution. I put it a bracket. Okay, I put a bracket or square block for that. What is the solution? Highly economical scheduling of 5 megawatt from these 2 units is possible only when I load unit 2 with the entire demand. Entire demand I should put it on machine 2 only, then only highly economic scheduling is possible. Therefore, that's a possible for economic loading of 5 megawatt run only unit 2. That's confused. You can see F1 must be 0, F2 must be 5. So it must be with only unit 2 operating for your